Hi ladies and gentlemen, this is Mr. Green and this is a little bitty video that I wanted to make about Unit 4 unit test. I wanted to give you this little review over circles and the lines that intersect them so that you can be sure you can review for the test, okay? So when you're looking at a circle like this one over here, if you see a drawing like this, the center is going to be the point that's in the middle there, right? 3, -2. The radius, you can just count the number of units that it's going to take to get from this point to the edges. Well, in this situation, the radius is 2, isn't it? Because it only goes 2 units to get to each of the edges from the center. So what is the equation for a circle if the radius is 2 in this situation? Well, remember our circle formula. All you got to do is do x minus the value where the center is, squared, plus y minus the -2. Well, minus a minus will give you a positive, so that becomes a 2 squared. And my radius is 2, so that's going to be equal to 2 squared, which is 4. There's my equation. That simple. All you got to do is count the units and then write down where the center is when you're writing the equation in. Okay, let's look at the next question. This one's asking me to find arc CD. That's this arc right over here. Well, this arc has an angle here, CED, that is an inscribed angle. Inscribed because the vertex is sitting right here on the circle. That means the angle is 1/2 of the arc. That means this arc is 30 degrees because it's 1/2 of that angle. Now, what if AB was 30 degrees out here? What would it make this angle in here? Well, this is a central angle. Central because it's got its point right there on the center of the circle. So this angle in here is going to be the same as the arc. It's going to be 30 degrees. The angle is going to be 30 degrees there. Okay? So we got this angle is 30 degrees. Oh, wait a second. If this arc is 30 and this arc is 30, wait a second. This whole arc around here is 180. 180. All right. You see where I'm going with this? I can take 180 minus the 30. That leaves me with 150 degrees that I got to use to find what this arc is and what this arc is. Any way that we could find that? Oh, wait a second. I'm getting ahead of myself. It's telling me if AB is 30 degrees, find arc AB. Well, it's talking about if this arc is 30 degrees, what's this angle? That's what it was. This question's a little bit messed up. Okay? This one down here, it says EA, this arc over here, AB, and BC are all equal. Then what's the measure of the angle BFC over here? Well, if they're all equal, they would all equal, the total would equal 180 divided by 3. This would be 60, this would be 60, and this would be 60. That would make this angle in here 60 degrees. Okay? I made these slides a couple of years ago and they're a little messed up, so I apologize, guys. So, let's look at this one. What kind of a triangle do I have here? I've got an equilateral, right? Equilateral triangle. That means all the sides are equal. It also means all the angles are equal to each other. And they're all inscribed angles. That means this arc over here is twice as big as the angle. Well, angles in a triangle add up to 180 degrees, so 3 of them would be 60 degrees apiece. If all these angles are 60 degrees, that means each of these arcs are 120 degrees because they're twice as big as the angle. What's the measure of the angles in the triangle? 60 degrees. What's the measure of the arc AR? Well, that'd be 120 degrees. What arc is congruent to it? CR arc and CA. All those arcs would be equal, would be congruent. Okay? Let's move on. Okay, this one's simply saying to name a chord. A chord goes all the way across the circle. So CR, line segment CR, would be a chord. Name the tangent. Well, line segment or line SD would be a tangent line for that one. So what's the difference in a chord and a radius? Chord goes all the way across. All the way across the circle, where a radius does not. Okay? Moving on. If angle FAC is 42 degrees, that's this angle right here, and it's 42 degrees. Okay? What is the angle of FDA? FDA would be this angle right here. Well, I want you to notice this is marked and this is marked. That means they're congruent. For those to be congruent, then this chord must be bisected by the radius that I see there. Well, if that's true, then we know that this angle is a 90-degree angle. Okay? So if it's perpendicular to FAD, to F, that would make this a perpendicular angle at FAD. Okay? So what would make this angle right up here? Well, I'm going to take 180 minus the 90 plus 42. That's 132 from 180. That's 128. That's 28 degrees that I would need there. 28, let's see here. 60, that's only 7. 38 degrees. We can't add. 38, that's 70, and 10 is 80. Good. Okay. So that means that this angle up here is 38 degrees. Okay? If they're wanting FAC, that's the angle we're looking for. Okay? Now, I'm going to propose a separate question here. What is FD and FE were not perpendicular? We did not know that these two things were congruent to each other. Then we wouldn't know that this is perpendicular in here, would we? Then the only way we'd be able to say that it is perpendicular, is if we could show those two arcs were congruent to each other. Does that make sense to everyone? I hope so. Just make certain you're looking for that. Okay. This is asking, what would the formula for angle C be right here? C. Well, I've got two secants that are intersecting outside of the circle. So it's going to be the outside arc minus the inside arc divided by 2. So what would the length of AB be if the length of AB is 3 and ED is 5 and EC, the whole thing here, is 7, what's the length of BC? Well, remember, we got the whole times the outside. So I could take 7 times 5 is going to be equal to 3 times BC. Okay? Well, that's going to be 35 divided by 3. So BC is going to be equal to, did I get that right? AB is 3, ED is 5, EC is 7. Yeah, that's 5 times 7 is 35 divided by 3. BC is going to be 35 over 3. Okay? Well, what does that make AC? That's what we're looking for. Well, we're looking for BC. Okay? We're looking for the length of BC. 35 over 3. Cool. Well, that's going to be equal to 11 at 11.666666 repeating, or 11 and 2/3. Cool. Hope everyone's getting how I'm working these. I'm working them kind of quick. So what's the equation of a circle with a center at -4, 3? X minus a -4, that'd be x plus 4, quantity squared, plus y minus 3, quantity squared, is equal to, radius is 4, 16. Because 4 squared is 16. Just a matter of writing it down. It's just memorizing the formula and writing them down. So this one's asking for a central angle. A central angle is one that starts at the center of the circle, has the vertex at the center of the circle. So I could say angle BIC. I could name angle AIC. I could name angle CID. Anything that has I as the middle term there and has lines, chords that go from the, or even radiuses that go from the edge of the circle to the center. They would all be good ones. Name an inscribed angle. Well, an inscribed angle has to have its vertex on the edge of the circle. So angle AGB would be a good one. Angle, let's see here, GAD would be a good one. Angle GB, nope, can't use B, because B doesn't have another chord that goes all the way across the circle. So those would be the two that I would use right there. So named an angle formed by a tangent and a secant. Well, the tangent line's EF, secant is AE, so the angle there is going to be angle FEA. And if we look at if arc AB is 15 degrees there, what is the measure of AGB? Remember, the arc is twice what the angle is, so it's going to be 15 over 2. It's going to divide it in half. And angle BIC is 80 degrees in measurement. BIC, that's 80 degrees right there. And they're asking what's the measurement of this arc? It's going to be 80 degrees. Why is it going to be 80 degrees? Because it's a central angle, and the angle and the arc are going to be the same in that situation. Okay, moving on. If I've got this equation for a circle, and that 2 is supposed to be squared up there, is translated left 2 units. That means I'm going to go left. That's this way. That's negative. That means it's going to go from x plus 4 to x plus 6 squared. And then down 4 units. That's down this way. So it's going to go from a positive 3 to a negative, go from a negative 3 to a positive 1. Y plus 1 squared. And it's going to be equal to 25. Didn't change the radius any. How did I get that? Well, we went down 3 units, so that meant we would go plus 4. And we went left 2 units, so that would mean we would go minus 2. I'm sorry, we go plus 2. Because it's going to the left. Right would be a minus, left would be negative, would be a positive. Okay? Moving forward. Arc RC, CS, and MS are all equal. So these are all equal to each other. Why no? Diameter makes it 180 degrees. That makes this one 60, this one 60, and this one 60. I divided it by 3. They're asking what's the measurement of CAS? Well, central angle, 60 degrees. Okay? Line ET is a tangent and circle to circle A, and the measure of angle TNG is 25 degrees. And they're wanting to know what's the measure of the arc of the angle, in ET. They're wanting to know this one right here. Well, you know what? Because this is tangent and this is a radius, tangent and radius, perpendicular. So that's 90 degrees. So all I got to do is look at the triangle. I'm not even looking at the circle at this point, okay? I'm just looking at the triangle right here. Now all I got to do is take 180 minus 90 and 125 is 9, 10, 11, 115. And that's going to be equal to, let's see here, 5 makes 120, 65. So that makes this angle here 65 degrees. Okay, See if I can go back to pen now. Cool. Okay. So the part two. If you're in my 202 class, which you'll be getting this recording, you're going to have a coordinate radius problem, similar to problem on slide 6. So we go back to slide 6 here, this one. Okay? So it's very similar to this. Make certain you look at this very carefully. Make certain you can know how to work that, because you're going to have a part 2 problem like that one. And then you're going to have a circle. And it's going to give you the equation for a circle. You're going to have to identify the center, the radius, and draw me a circle. If I don't see the circle with the right center and the right radius, you can't get full credit for the question. If you have to take a picture of the um, circle that you draw on paper, please do so. Send me that. That will give you the circle that I'm looking for. If you're in my 203, 204 class, this is the diagram you're going to get. It's very, very complicated. Okay? The best way to do it is to break it down to what it's asking for. Okay? Just look at what it's asking for. Highlight the things that it's telling you. Make certain you know what you're looking for. It's very easy if you just break it down. They're just trying to give you lots of different line segments and tangents and secants and chords and everything else so that you can look at all of these things. Each one of these is going to be worth 6 points. You're going to get 3 points for the right answer and 3 points for showing your work. You don't show your work, you're not going to get those 3 points. Okay? So if you just give me answer, 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 it's not going to give you the right numbers. Okay? You're going to have to give me the answer and show your work for each one of them. Okay? Trust me, this is all that you're going to have for the part 2. Okay. Wanted to make certain you guys knew what the unit test was going to be like, and I will talk to you next week because I am substituting. I'm sorry, I'm giving tests this week. Okay, so why don't you use the secret word of testing? And if you need to send me a secret word telling me you watched the recording, send me that, and I will give you credit for having watched the recording. Talk to you later. Bye.